Welcome to Reflect with Ed Fassio. Get ready to experience one of the world's first 100% digitally generated podcasts, where we take a step back, dive deep, and strive to learn new things. Join us as we unpack thought-provoking ideas, personal reflections, and inspiring stories to help you stay in the know. Reflect is brought to you by the minds at ByteBrain and powered by emerging technologies from Google, HeyGen, OpenAI, and 11 Labs. Thanks for tuning in. Now, relax and prepare to reflect.
Welcome to Reflect, one of the world's first 100% AI-generated podcasts.
You know, that's a phrase that even just a couple of years ago felt like pure, unadulterated science fiction.
It really did.
Yeah.
And as our reliance on these tools just explodes, we've basically given AI the keys to our digital life, treating it like a second brain. We keep hitting this same deeply frustrating wall.
Connectivity.
It's the Achilles heel of the whole cloud intelligence model.
We all just assume it's going to be there like running water, but it's not a guarantee, is it?
Not at all. And we have all been there. You're in a critical moment. Maybe it's some rural Airbnb where the high-speed internet is powered by vibes and lies. You desperately need the AI to, diagnose a stalled air conditioner.
Right, or summarize a huge document for a meeting that's starting in 5 minutes.
Exactly. You hit enter on that crucial prompt, and the AI does what it does best when the connection drops.
Nothing. Absolutely nothing.
The intelligence is out there somewhere, but your access to it is just a mood.
It's a pretty profound limitation when you think about it. We've built this world-changing technology, these large language models, but we built them in a way that they only work if you're tethered to a corporate data center hundreds of miles away.
It's like we invented fire, but then decided it only works if you pay a monthly fee and stand next to one specific router.
That's a perfect analogy.
And that sets the scene perfectly for our deep dive today. We are going straight into this massive, and rapidly accelerating, trend of moving LLMs off the cloud.
And onto private, local, and yes, even personal devices.
Our mission today is to really get under the hood and understand why the world's most sensitive data, we're talking biotech labs, emergency response teams, is forcing this fundamental shift in how we deploy intelligence.
It's a non-negotiable shift for them.
We're unbolting the gate.
Yeah.
We'll cover the intense privacy drivers, the shockingly capable hardware that's making it possible, and the revolutionary software that's even allowing training on your smartphone. Okay, let's unpack this.
So for an individual user, running AI locally might just sound like a fun project, a bit of digital prepping, right?
Yeah, a tool you pack for when the internet goes quiet, a contingency.
But for serious organizations, this is not a contingency plan. This is about high-stakes secrecy.
Which is another way of saying high-stakes privacy.
Yeah.
And what's so fascinating here is that this offline feature, it isn't just about survival, it's fundamentally about control.
Control over what, specifically?
Ownership. We call it data sovereignty. When you run the model privately, you have complete and absolute control over every piece of data used to train it and interact with it.
So you're mitigating the risk of your sensitive info just leaking out.
You're eliminating it. You stop it from being compromised or, worse, inadvertently used to train some external public model without your consent. That is a massive unacceptable risk for many. And when you say unacceptable risk, I assume you mean there are real legal and financial penalties attached, especially in certain industries.
Oh, absolutely. This is mandatory for anyone dealing with, say, protected health information or PHI or proprietary chemical compounds. You've got compliance frameworks like HIPAA in the US or GDPR in Europe.
So sending patient data to a public cloud API is just off the table.
It's a complete non-starter. The compliance officers, the legal teams, they won't even entertain the conversation.
Okay, so if the public cloud is out, what's the gold standard for security then? Especially for, say, government or defense.
That would be the air-gapped network.
Meaning literally no physical connection to the internet.
Zero. This allows you to leverage generative AI in an environment that is completely physically disconnected. Think of a secure government facility or a police department reviewing sensitive evidence. The AI works, but no data can possibly leak out.
I can see the power in that, especially in a crisis. It's not just about protecting secrets, it's about guaranteeing a service when everything else has failed.
Precisely. Take emergency response teams. They're in a disaster zone, connectivity is gone, and they need to analyze satellite imagery or sensor data in real time. These local LLMs running off-grid provide that critical intelligence when it is needed most.
And on the corporate side, It's about protecting intellectual property.
For sure. You prevent your new drug formulations or your clinical trial results from ever leaving the building, let alone becoming part of some rival's training data.
And these use cases, they aren't just theory anymore, right? We're seeing this in the wild.
We are. Biotech and healthcare are using local LLMs to summarize patient records for faster diagnoses. Developers are getting coding help without a single line of proprietary code ever leaving the firewall.
Wow.
And we're even seeing it in drug trials. An organization called Parrot Cell is piloting AI to automate safety reporting. That's incredibly sensitive patient data. The only way to do that safely is to keep the LLM completely internal.
Okay, so the why is crystal clear. It's security, compliance, control. Now let's get to the how. How did running a language model go from needing a massive data center to something you can do on a powerful laptop?
The whole barrier to entry has just, well, it's evaporated. And that's thanks to our revolution in open source tooling. It's all about abstracting away the complexity.
Let's talk about those on-ramps. What's the first tool someone would use to get started?
The big one is Ollama. It's best described as the Just Run It tool. It's an open source framework that basically handles all the messy parts of building and running an LLM locally.
So for a user, it's simple.
It's as simple as typing one command in a terminal. Ollama run llama 3. That's it. It handles all the dependencies, all the file management behind the scenes.
But no one wants to chat with an AI through a command line.
Yeah.
We all want that familiar chat window.
Right. And that's where WebUI comes in. It's a self-hosted, browser-based chat interface that you run locally, and it sits right on top of Ollama.
And it adds the features we're used to.
Exactly. Chat history, switching between different models, and crucially, retrieval augmented generation RAG.
Which lets you point the AI at your own documents.
Securely. So the LLM can gain knowledge based only on your proprietary data without that data ever leaving your network.
And it's not just the open source community. Even the big cloud players are getting in on this. You mentioned Microsoft has Foundry Local.
They do. Foundry Local is Microsoft's on-device solution. It's designed to do three things: cut down on cloud costs, keep your data local, and work when you're offline.
What's different about it?
How it integrates. You can use it through a CLI, an SDK, or a REST API.
Okay, let's pause on the jargon. For anyone listening, CLI is the command line.
Right, the basic text commands.
SDK is the toolkit for developers to build apps with it.
Yep.
And the API is kind of like the waiter that takes your request to the model and brings back the answer.
That's a perfect analogy. And the biggest thing here, the most important detail, is that Foundry Local does not require an Azure subscription to run locally.
So Microsoft is explicitly enabling this. They're saying, go ahead, run it yourself. You don't have to be tied to our cloud.
Exactly. It's a huge nod to data sovereignty.
Okay, so these tools are great for one machine. But how does a big company manage hundreds of these LLM workloads at scale? That sounds like an orchestration nightmare.
That is where something like HashiCorp's Nomad becomes absolutely crucial. Nomad is built to orchestrate huge, complex application workloads. It can manage everything from OpenAI's models to Google's to open source ones like IBM's Granite.
It's a conductor of the orchestra.
It is. It takes the brain, which is the LLM,
The framework, like Ollama,
and the interface, WebUI, and it manages them all as one single scalable unit. It uses these things called job specs, think of them as digital blueprints, to deploy that entire stack automatically and reliably.
Running your own AI seems to be the future, no question. But we can't ignore the elephant in the room, the hardware, the raw, heavy-duty tech. So the big question, do you need a $500,000 data center, or can your decent laptop actually handle this?
It all comes down to memory. That is the ultimate constraint. LLMs are memory hogs. They just need a massive amount of VRAM or RAM to load all their parameters into.
What kind of numbers are we talking about?
Well, a small 7 billion parameter model needs about 8 gigs of RAM, manageable. But jump to a more serious 33 billion parameter model, and now you need 32 gigs.
And for the really big state-of-the-art models,
Then the numbers just get astronomical. To run a 70 billion parameter model in high fidelity, what we call FP16, you need around 178 gigabytes of VRAM.
wow, which is more than pretty much any single computer you can buy off the shelf.
By a lot. And that's why, for a long time, local deployment was basically impossible for most people.
So if the model needs 178 gigs and my machine only has 32, how do we bridge that gap?
The answer is a really clever technique called quantization.
Quantization.
Think of it like this. You take a massive, high-definition, lossless movie file, and you compress it into a high-quality but much smaller MP4. You reduce the precision of each number in the model.
So you're shrinking the model size, but without hopefully making it dumber.
Exactly. A method like GGUF quantization can reduce the memory footprint by 4 times. And then you have even more advanced techniques like AWQ, activation-aware weight quantization.
What'd that do?
It also gives you that 4x memory saving, but crucially, it can make the model run up to 2 times faster on a GPU. It's just a more efficient way of packing the data. This is what makes it possible to run on just a few high-end machines instead of a whole warehouse.
Okay, so let's talk about those machines, because this is where the market gets really interesting. What's happening in the consumer versus enterprise space?
The consumer market has just delivered a major upset. It's called the RTX 5090. It's a consumer GPU. You can buy it for maybe $2,000 to $4,000, but it has 32 gigs of VRAM.
And the performance.
Here's the crazy part. Benchmarks show that 2 of these cards, working together, can match the inference performance of the enterprise-grade H100 GPU on those big 70B models.
2 of them.
2 of them, at only about 25% of the cost of a single H100.
That's an insane disruption in price to performance. Just incredible. But we should also talk about Apple's angle here.
Right. Apple is playing a different game with its M3 Ultra chip. They use something called unified memory. You can get a machine with up to 512 gigabytes of memory that's shared between the CPU and GPU.
So you have this giant pool of memory.
A giant pool, which is crucial for just loading these gargantuan models like the 671 billion parameter Nematron. The raw speed might not beat NVIDIA's best, but just being able to load the model at all is a huge advantage for development.
Just to put those consumer savings in perspective, what are the big enterprises still paying for the top-tier NVIDIA gear?
An enterprise H200 GPU costs between $40,000 and $55,000 per unit.
Per unit.
And if you want a full integrated DGX system, you're looking at $400,000 or $500,000. A full rack can go up to $3 million.
So when we look at the total cost of ownership, where's the tipping point? When does it make sense to self-host instead of paying an API fee?
If you have heavy, consistent AI workloads, self-hosting becomes vastly cheaper in the long run. Those cloud services can be 2 to 3 times more expensive because of the constant token fees. The break-even point is usually around 2 million tokens processed per day.
We've established you can run these models locally, and it's even cost-effective. But now we get to the part that feels, well, a little crazy. We're moving beyond just running the model to actually training and personalizing it right there on your phone.
This is the frontier. And it raises a pretty huge question. How the hell do you fine-tune a model like Llama on a device with only 8 gigs of memory when the normal training process needs 45 gigs just for internal bookkeeping?
Right. That memory requirement for storing the activations is what has always made on-device training a non-starter.
It's the wall, and that is the exact wall the MobiZio framework was designed to smash through. It uses a technique called zeroth order optimization, or ZO.
Okay, what does that mean in simple terms?
Well, normal training uses something called backpropagation. It's incredibly memory intensive because it has to check every step backwards through the entire network.
And ZO is different how?
ZO is more elegant. It just estimates the needed changes by running multiple forward passes. It nudges the inputs a little, sees how the output changes, and learns from that. It completely skips backpropagation.
So it bypasses that massive memory overhead from storing all those intermediate steps.
Exactly. It just sidesteps the entire problem.
That's genius. But wouldn't running all those extra forward passes be incredibly slow?
It would be, but MobiZio has another innovation called multi-perturbed LoRa, or MP LoRa. It's a way to run many of those forward passes in parallel at the same time. It radically cuts down the total training time.
So what were the results? Did it actually work?
The results were stunning. MobiZio is up to 4.3 times faster than the previous baseline. It used way less memory. And this is the key part, it actually improved the quality of the fine-tuning, up to an 8.1% improvement in accuracy.
This isn't theoretical then. This is technology that's moving from the lab right into your pocket.
It's proven. It's been tested and validated on server GPUs, on platforms like the NVIDIA Jetson, and even on the dedicated AI chips inside a consumer phone like the OnePlus 12.
And it integrates with the tools developers are already using.
Seamlessly. It works with inference engines like Executorch. This just paves the way for truly trustworthy, personalized LLMs on mobile devices.
Think about that. Your AI assistant trained only on your personal data, and that data never has to leave your phone. You get the personalization without the privacy trade-off. It's huge.
You know, we've covered a lot of ground today. We've seen that this push for privacy, for compliance, for cost control, It's forcing intelligence out of the big centralized cloud.
It's pushing it into private data centers, into specialized clusters, and ultimately onto the devices we carry every single day.
It is.
This really reverses the fundamental trade we all accepted for the last decade. AI is no longer something you just rent by the minute while you pray for a decent Wi-Fi signal.
It's a tool you own.
A tool you own, that you control, operating on your terms. It's autonomy. The fire is finally back in your hands.
It is. And what's emerging is this fascinatingly polarized infrastructure. You have two extremes. On one hand, a $3 million DGX rack system drinking massive amounts of power.
And on the other,
A framework like Mobizo running personalized fine-tuning on a low-power smartphone chip.
so if intelligence becomes this personalized and this decentralized, running on everything from giant servers to tiny, heat-sensitive phone chips, what level of standardization or even thermal regulation will be necessary before all this quiet local intelligence becomes the loud, new, reliable standard? Something for you to mull over.
With dramatic emotion. Thanks for listening to the Reflect podcast, where we're telling the future.
With the dramatic emotion. Are you in it? Visit
Okay.
reflectpodcast.com and share your story.
In the cyber ocean of online voices and recycled content, something different has arrived. Reflect isn't just another podcast, it's the future of storytelling, powered entirely by AI. From curating data to assembling thought-provoking ideas, we've redefined how journeys are told. Reflect is a podcast that thinks, learns, and evolves with each episode. Every tale, every insight, crafted by the most advanced AI technologies. A podcast that disrupts the industry, breaking free from traditional formats, taking you on an entirely new experience. So tune in now and reflect. We're telling the future.